Have ripple tank experiments misled us into thinking photons act like water waves? Welcome back to the Quantum Lab. I'm Joseph Stute. The question posed in the opening will be answered in a few moments. But first, let's take a look at a few ripple tank videos found on social media. The presenters proclaim photons act like water waves. No, I say they do not, and will present experimental evidence to prove my point. To help us keep track of when photons act like water waves, and when they do not during my demonstrations, I have created a Quantum Olympics scoreboard. Also coming up are a few tips for experimenters. This is my simplified ripple tank setup. Instead of springs, hooks, and a plug-in electric motor, I purchased a scrap piece of 1/2 inch PVC tubing at my local hardware store. This is the view below the ripple tank. The demonstration shows waves bending after passing through a single slit. There is no detectable interference pattern. Let's take a look at the result of a laser aimed at a single slit. Two surprising reflection patterns are created on the screen. You can watch the experiment that produced the two patterns by clicking here. Score 1 point for photons do not act like water waves. Change commonly accepted experimental parameters slightly, then keep testing. That's how I discovered two patterns from one slit. Back to my ripple tank. This time, instead of a single slit, I use an edge. Like the single slit demonstration, we see waves bend, but they never interfere. I will repeat the single edge experiment, only this time using a laser. I use two screens. A large fixed green screen and a movable white screen is used to unexpectedly twist the imagination. Here we see two patterns, created when a laser is aimed at one edge of the caliper I use in all my video demonstrations. To better see the patterns, let's go to lights out. The light-dark pattern on the left is easy to see. The one on the right is harder to see because the pattern spacing is so very small. I have found two ways for expanding small patterns. One, move the screen far away from the laser. When recently experimenting with a 2.5 millimeter diameter pin, the screen had to be placed 25 meters from the laser. Check this out. A simpler way is to place the screen almost parallel to the laser beam, like this. How my edge demonstration's laser dot turns into a light-dark pattern might be confusing. The laser dot is composed of light and dark spots we cannot see because they are small and close together. Twisting the screen spreads the light and dark spots, similar to spreading cards on a table. Score another point for photons do not act like water waves. Some patterns are best viewed with the screen at an angle or far from the laser. When waves flow past a ramp set at a slight angle, they only bend, never interfere. When the ramp's angle is increased, we see a wave interference pattern. I will do the same ramp experiment, only this time with a laser. Aiming a laser parallel to a polished stainless steel strip was the subject of my second video. By adding a slight ramp to the strip, we see reflected photons form a light-dark pattern. With a small twist of the strip, the pattern disappears. This setup shows photons act the exact opposite of water waves. Photons do not act like water waves. It's another point. Test something new. There are many surprises to discover. This is really getting monotonous. Obviously, photons do not act like water waves. I could not find one experiment where they did. Yet there are hundreds of people on social media that say photons act like water waves. As our friend Spock would say,
most illogical.
May I suggest? Stop following the herd, sell the Ripple Tank, and have fun doing laser experiments. If you'd like to see more experiments debunking Young's wave theory, visit jsquantumlab.com. Hit that like button and subscribe if you'd like to see future videos.